So now with the speed aspect taken care of, we look at how to design the reference. The question that that came earlier in the class कि bit cell की तो एक ही bit line है. How do you get the reference bit line? So what we do is, in a typical DRAM, we would use a level restoring sense amplifier. What does level restoring sense amplifier mean? It means that there is no pass gate in between now. So the sense amplifier is connected and coupled with the bit line at all times. Are you able to see this? When the sense amplifier will operate, the bit lines would go to 0 and 1.
So how this sense amplifier operation is happening? Can you?
So how does the regular sense amplifier operation happens? Can you describe that? I will then tell the changes. What do we do in a regular sense amplifier?
तो यहाँ पे बीच में हमारे पास गेट होते थे, फिर उनको हम लोग हाई करते थे तो हमारा बाहर वाला बिट लाइन का डेटा सेंस एम्पलीफायर में लैच हो जाता था। फिर
नहीं, यहाँ पे पास गेट होते थे. You would turn off these pass gates and turn this one on.
Sorry sir. Yes,
when
sir.
you turn this one on, that was when latching action happened.
Yes sir. Yes sir. अच्छा मैंने
exactly the same here also.
So, लेकिन वहाँ यहाँ पे तो हम लोग का कनेक्टेड ही है सेंस एम्पलीफायर से दोनों बिट लाइन, और वहां पे हम लोग पास गेट्स ऑफ करके ये सेंस इनेबल ऑन करते थे, ऐसे ऐसे ऑन करते थे। तो यहाँ पे अब ये कनेक्टेड है तो किस तरीके से
कनेक्टेड है? दैट इज व्हाई इट इज कॉल्ड लेवल रिस्टोरिंग. बिट लाइन पे 100 मिलीवोल्ट का डिस्चार्ज हुआ, लेकिन आपने उस 100 मिलीवोल्ट के डिस्चार्ज को सेंस कर लिया और उसको पूरा 0 तक ले गए.
ओके ओके
आपने, और जब आप इस तरफ को पूरा 0 पे लेके गए तो क्या हुआ? साथ ही साथ DRAM सेल के अंदर जो कैपेसिटर था वो भी पूरा का पूरा चार्ज स्लैश डिस्चार्ज हो गया.
यस सर.
आपने रिफ्रेश साइकिल भी साथ साथ चला ली बाय यूजिंग दिस काइंड ऑफ अ सेंस एम्पलीफायर.
ओके यस सर. सर ये वाला भी एक डाउट था कि ये रिफ्रेश, हाँ अभी वो भी क्लियर हो गया. ओके सर.
ठीक है. तो ये सेकंड बिट लाइन कहाँ से आएगी? तो इसको बनाने के लिए मल्टीपल तरीके करे जा सकते हैं. वन थिंग कुड बी दैट फॉर द सेंस एम्पलीफायर यू से दैट alternate rows will, the bit lines connected to alternate rows will be called bit line. Bit line connected to the other alternate set of rows will be called the bit line bar. Okay, and now both are connected to the sense amplifier in between. One acts as a reference, the other acts as a, so which one would act as a reference? Let us say I am selecting, so for my particular read operation I selected this particular row. So let us say this was row 0, row 1, row 2, row 3, 4 and so on. So which bit line, or where do we now get the reference from? Let us say row 0 was the one that was selected. It means this side would discharge if there was a 0 stored here. The problem is if this does not have, or if the, how do I put it? We'll come to that later. So the thing is that you access one row and the remaining rows act as the reference. So one bit line, second bit line. There are two bit lines and they act as a reference.
So when bit line come, either bit line or bit line bar will be selected. So whichever is not selected will act as a reference.
Okay. Yes. ठीक है ना? So each BL acts as a reference for the other. This was the patent by Mitsubishi. So what did others do? Others also said that, okay, let us have a dummy cell somewhere. And if I am selecting this bank, that is, let us say I am selecting this particular cell, then the reference would come from this bank, the other one. Is that okay? Are you able to see this? So you generated a reference again, but now from the bit line on the other side of the array. So jo humne, you're talking about that there is this kind of an organization of pages. यहाँ पे 128 के थे, यहाँ पे 128 के थे. They were sharing the sense amplifier. This is how they were sharing the sense amplifier.
Yes,
Is
sir.
it okay?
Yes, sir.
So now, any further questions here?
Yes sir, वो sense amplifier पर like उसका operation, वो जो bitline है that is connected to precharge वाला point, internal node को हम जो precharge कर रहे हैं. Like earlier we had device to distinguish between them. अभी internal node precharge and bitline precharge एक ही हो गया. Like they are shorted, right?
Yeah. In DRAM, yes, that is what happens. As you read, the refresh also happens simultaneously.
Refresh not, I'm talking about the precharge, like bitline को जो precharge कर रहे हैं, and in SRAM bitline precharge and sense amplifier का internal node precharge, they were two different things, like sometime difference was there.
Oh yes, because there was an internal node in the sense amplifier. This sense amplifier doesn't even have an internal node, so दो अलग-अलग precharge की तो बात ही नहीं आएगी ना, है ना? Any questions? Clear?
टाइमिंग ग्राफ्स एक्सप्लेन कर सकते हैं सर आप, जो टाइमिंग वो था ना सेंस एम्पलीफायर की स्लाइड में.
So your bit line, and so you use first equalize. Okay? Equalize में क्या होगा? आपने एक bit, आप पिछली cycle में you had, let us say, taken one bit line to VDD, other bit line to 0. You say I will equalize. As soon as you equalize, what happens? VDD and 0, both the bit lines have same capacitance. So what is the voltage at both the bit lines then?
V/2.
Are you able to see that VDD by 2 generation does not really require a charge, doesn't really require a regulator or a potential divider or anything?
But you have connected the supply VDD/2. How do we get that is the question, right?
I'm sorry?
That the equalizer प्रीचार्ज को जो हमने सप्लाई दिया है वो VDD/2 दिया है, राइट?
कहाँ दिया है?
प्रॉपर कुछ लिखा है ना VDD/2.
Oh, one bit line means differential is VCCS/2. That is something else. So that has become overlapped. Don't worry about that.
Okay.
So what we are saying is that if this was due to sense amplifier operation, this was charged to 1 and this was charged to 0. When you will equalize, what happens? Both become VDD/2.
Yes, sir. Due to equalization, both of them
Charge
become
sharing. Due to charge
yes.
sharing.
Yes, sir. Yes, sir. Yes.
Okay? You do not need the regulator at all.
Yes, sir.
Then you would give the word line. So once the word line comes, depending on whether your memory cell had a 0 or a 1, one of the bit lines would rise or fall a little. SAP will go high, SAN will go, so SAP was high, it will start to go low. So this PMOS turns on. SAN was low, it starts to go high. So this NMOS turns on. So what that means is that this latch is now operational. Are you able to see this? As soon as the latch operation starts, I will distinguish between 0 and 1. Then at the beginning of next cycle, I will initiate equalization again.
Sir, where is the bit line charging वाला part? ये equalizing part ही bit line pre-charge हो गया, right?
Bitline pre-charge, दोबारा से बोलो.
Bit line pre-charge and equalizing process ये
same है.
same ही है, right?
Yes.
And
ठीक
what
है?
are these extra capacitors CB, CCL?
Oh, they're just shown to represent the bitline capacitance there.
Thank you.
So that is